Hi folks, this is Darren with My RV Works. I'm just going to do a real quick intro to the video you're about to watch. It started off as being one video where we're going to be doing several things to this furnace, but I decided after the fact to chop it up into two parts. So this will be the first part where we're going to dive in to an intermittent extinguishing and igniting fault within the burn chamber. But during this video you're about to watch, we are going to go into all these wires and how they work, and we're going to take our meter and probe into the circuit as it's working its way through the furnace. I do not have a lot of videos on the furnaces with these older time delay relays on them, and so in this video we are going to go pretty deep into the time delay relay, and we're going to be probing the different points on here, and then we're going to be diagnosing what would cause this furnace to have an intermittent fault with extinguishing and igniting. The second part of the video, which will be part two, which is going to be its own standalone video, is going to be replacing the motor. So with that, let's jump right into the first part of the video where we're going to start digging into some of these sensor signals in the wires and figuring out what would cause the intermittent fault. I hope you enjoy the videos. Thanks for watching. Hi folks, this is Darren with My RV Works. Today we have another furnace for you. Now on our playlist, myrvworks.com, you can get to it that way, but on YouTube, Rumble, we have playlists that we've set up for you. And so you go to the furnace playlist and there's a wealth of information that I've created for you, and you can just watch those videos to learn more about furnaces and how to diagnose them and how to fix them. This furnace has two issues. The first issue is the motor is squealing, so we're going to be replacing the motor. I have a couple furnace videos where we're replacing the motor. This one's down deep inside and you have to take quite a few parts apart to get to the motor, so you can follow along on how I do that. I'll go ahead and let you listen to it. It's squealing. But the second thing this furnace is doing is a very intermittent issue. The customer states that the furnace will run, it'll produce heat, and yes, even though the motor is squealing, that's fine, it's still producing heat. But then intermittently, it will stop producing heat. The motor will still run and squeal, but the furnace will extinguish inside, and it'll just blow room air, not hot air. And then it'll start back up again, and then it'll extinguish, and then it'll start back up again, it'll extinguish. Now, why is it doing that? There are two things that might be an indication that it's doing that. The first thing is the control board is not able to detect the flame, okay? And we will discuss that when we get into trying to figure out why it's intermittently igniting and extinguishing all inside. The first being that the control board does not detect the flame. That could be the control board itself, it could be the electrode wire, it could be the electrode itself, it could be the gap over the burner. Okay, so it could be any of those situations would cause the control board to not detect flame, and if the control board cannot detect flame and there's still a call for heat, it's going to shut the gas valve down. It will not allow gas to flow through. Another instance where you may not detect flame is if you run out of propane. Certainly if you run out of propane, your flame has extinguished, and the control board at that point then says, I see no flame. You know, even though everything's just perfectly dialed in, you've got a perfect furnace, but you run out of propane, then certainly the control board cannot detect the flame because there is no flame because you've lost propane, and the control board will then shut off the gas valve. So the first issue is it cannot detect flame, and like we said, control board, electrode wire, electrode gap, the electrode itself. We're going to get into all that when we get inside the furnace. The second thing that it could be is a sail switch fault or a high temperature fault. Okay, now the sail switch fault and the high temperature fault, they're on a daisy chain circuit. They comes back from the thermostat. So you've got 12 volts at the thermostat, and the thermostat, well, see, I've got to be careful when I make that statement because on there's several different styles of thermostats, and there's several different air conditioners. There's several different ways to wire a furnace. So I can't just make a blanket statement and say your signal is coming from X or Y, okay? On a lot of your Dometic air conditioners, the thermostat is controlling the air conditioner and the thermostat is controlling the furnace. But the thermostat is communicating to the air conditioner up in the ceiling, and the furnace wires run through the wall up into the ceiling plenum at your air conditioner, okay? And so I'm holding myself back here like a horse, and I'm like, I could go into detail, but I have covered this on many of my other playlists on furnaces. But let me just land the plane on that. Dometic furnaces, a lot of times their control is done up in the air conditioner plenum, a Suburban furnace or a Suburban air conditioner, Dometic air conditioner, Suburban air conditioner. More specifically, Dometic thermostat, Suburban thermostat. Dometic thermostat is communicating to the air conditioner closes the wires that turn the furnace on. The Suburban, not all Suburban thermostats, but a lot of your Suburban thermostats, boy, it's a mouthful. The control to turn the furnace on is done at the thermostat. Then you have the kind of thermostat that's just on a wall, and it's its own dedicated thermostat. So there's no blanket statement on how these things are wired. However, at the end of the day, this furnace needs 2 wires to make contact. It needs 12 volts coming back to it. And even that can't be a blanket statement, because on some of your Suburban thermostats, you only have 1 wire coming back. So we'll save that for another time, but let me stay on focus here, stay on point. We were talking about the furnace having an intermittent issue. Extinguishing its flame, starting its flame, extinguishing its flame, starting its flame. I said that one thing could be the electrode wire, the ceramic in the electrode gap, or the control board itself. All of those things would be an indication of the flame extinguishing, the control board extinguishing the flame because it shut off the gas valve. The other thing I said is it could be a faulty sail switch, it could be a faulty high temperature switch, and I'm pointing to them. This is a sail switch on this furnace here. Let's see here. On this SF30F, the sail switch is right here. Some of them are inside this cover. And then on this one, on the back side of it right here, we'll spin it around, you'll get to see it, is the high temperature switch. You've got the blue dot, green dot, orange dot, and all that has to do with the BTUs of the furnace and its temperature where it trips off. Make sure that when you replace that, you replace it with the correct color dot thermostat, okay? So if your furnace is blowing heat out and it's got some restriction in the ductwork, then all that heat's backing up and it's gonna trip this high temperature switch, which is here in the back. And then the furnace will extinguish the flame, it will cool down your thermostat here, and it will start back up again. So we see that an awful lot. I've got a bore scope and I've put it inside of some RV where these things go through the ductwork and they come out and they come up on the floor. I've taken my bore scope and shown it inside, and you can see where the ductwork that the manufacturer used has crushed or come untaped, or it's just not a nice smooth flow. And that's unfortunate when that happens, because it's really difficult to get in there and fix that kind of stuff. But we do see it from time to time, and that causes the heat to back up inside of the furnace. So if your high temperature switch would trip, then that would cause this furnace to intermittently extinguish itself and light itself, extinguish itself and light itself. When the sail switch trips, though, we don't see that as often as extinguishing and igniting, extinguishing and igniting. Because when the sail switch trips, the control board needs to see the furnace stop and start again, okay? And so if your issue is with your sail switch, then it's not likely that it's going to be one of these intermittent things where it'll keep running, but ignite and extinguish, ignite and extinguish, ignite and extinguish. So that's likely not a sail switch fault, okay? The way the sail switch works with open and close, the control board, it needs to it's like a latching relay, okay, if you're a controls engineer. It needs to see it start from a zero state, an open state, okay? So not to say that all control boards are the same, because these things are like a mixed bag, but typically when we see the fault that this one's having, it's typically not a sail switch problem. It's either the high temperature switch, the electrode wire, or the control board, okay? So I guess I wanted to throw that out there so that if your symptom is that your furnace is igniting, extinguishing, igniting, extinguishing, igniting, extinguishing, these would be some things that I would want you to look at. Now, let me, at this point, go ahead and start it up, and then you can hear the squealing, okay, just for everybody's benefit. Now, what I've got here is I've got a battery and I've got a propane cylinder here and a little test jig that I know is set to the correct pressure. And let's see, I'm looking for these, another set of wires right here. Okay. So, and then I've got my little waggle connector. So when I connect these 2 wires, I am gonna basically become the thermostat, these 2 wires here. These are wires that leave the furnace. Typically, when they leave the furnace, they're blue, and I don't know if you can see right here, but they are blue. They leave the furnace as blue wires. They could be, in this instance, they're 2 light blue. Sometimes they're blue with white stripes, sometimes they're dark blue, but they're gonna have some element of blue on the wires that leave, regardless of your manufacturer of your furnace. Maybe that's a standard in the industry. I don't know. But all I know is there's blue wires. Now this one I also notice has a time delay relay on it. So when I connect these, there's going to be an interval of time before the furnace starts. So all I'm doing right now is letting you listen for, we'll actually let it go up and see if it'll ignite and extinguish, ignite and extinguish. In the RV, I did recognize that. I did see it doing that, and that's when I pulled the furnace out. Well, certainly we were going to pull the furnace because we were going to replace the motor, but it was extinguishing and igniting. And let's let you listen to it. And I tried it just a few minutes ago to see, before I started filming, to see if I can get it to extinguish, ignite, because I wanted you to go through the benefit of me troubleshooting and probing into different things. Before you start taking the thing apart, you can follow the trail of all these different circuits and see which signal is telling the control board to turn itself off, to extinguish the flame. And so I wanted to show you that. Now, if it'll do it, great, we'll break the meter out and I'll show you. If not, then I will walk you through how I would have diagnosed this without having to take the thing apart. So we're gonna connect the wires here. There's gonna be an interval of time, I don't know, a couple seconds. And what's happening is there's a bimetallic relay in here. It's heating itself up right now, and then it'll trip like an oil can, and then the thing will start. You'll hear the thing squealing. About now. How about now? How about now? There we go. You hear a little bit of an audible squeal. There it goes. Okay, so that's terrible. I'm gonna let it go ahead and ignite. And what I wanna do is see if we can get this thing to start, stop, start, stop. So it is producing heat. I can hear the rumble. I'm gonna take my eyeball and look in this mirror right here, or this little lens, and I can see my flame. Now, regardless of the squeak, now the squeak is not a serviceable part. They do not make fittings on there that you could lubricate that bearing. It is a sealed bearing. So unfortunately, when your motor is squealing like that, your option, replace the motor. Some of you are going to have issues finding the motor. Like for example, this one is an SF30F. It's not enough to go to the parts counter and say you need a motor for a Suburban SF30F, because they've changed it from, like, I think it's a 2.5 inch to a 3 inch, and that's based off of the serial number. So when you go get parts for these things, you need to know your model number, in this instance, Suburban SF30F, and your serial number. On a Suburban appliance, the first 2 digits of that serial number is the year of manufacture. So they track these things based off of the year it was made, and then from that, they can determine what size motor goes in this furnace. So we went ahead and got a motor for it. You hear this thing. And we needed to know the serial number. So if you're going online or something and you say, hey, I need a motor for an SF30F, and the people come back and say, oh yeah, we got one, but they never asked you for the serial number, they're doing you a disservice. Don't be surprised if you get the wrong motor, okay? So I want to be clear on that. Model number and serial number. A lot of times people will come to us and say, hey, I've got a 2015 J-Coat J-Flat. That means nothing to parts people in the RV industry. If we were to go to the Napa counter or AutoZone or something, yeah, I've got a 2015 Ford F350. They can look up that truck because they're all the same. But when it comes to RV parts, we really don't, telling us what kind of RV you have, it doesn't really help us much. We need to know the model number, the serial number of the appliance, and the serial number is very, very, very important. Don't forget the serial number. Like I said, in Suburban, the first 2 digits are the year of manufacture. So what we experiencing on this one is the motor's behaving itself, and this is where the customer would just deal with it. It goes through its squealing and then it comes back, but it's not extinguished yet. It's still putting out some pretty good heat right now. But while I was there, it was igniting and extinguishing, igniting and extinguishing. So what I'm going to do is let this thing cool down, because we're going to be going inside of it. And so basically I'm just going to take my connector and take my wire off. That just extinguished the flame. It's going to go through typically around a 90-second cool down. It's called a post-purge. And what we're doing is we're waiting for this relay right here to cool itself down, and then the little tin can thing, the bimetallic part inside, will cool down, and then the little metal thing will flip open, opening our circuit. This right here, this little relay right here, is what's controlling the fan motor, okay? So once we get this thing cooled down, we're going to be, let me benefit you from tracking some of the signals. Let's do that on this video. I'll take my meter, I'll set it up, and we'll start it, stop it, start it, stop it. You can see some of the signals coming into the control board, and I really, really wish that this thing was intermittent. That would have been really valuable. It was doing it in the RV, but I can't get it to do it here on my bench. But we'll follow the trail anyway. So I'm gonna let this cool down a little bit before I touch it, and then maybe set the camera up, and then we will demonstrate how you can diagnose your furnace in place without you pulling it, and what wires to probe and what you should expect to see on what wires. Okay, on this furnace, let's look at the wiring. I'm gonna follow the wires so that we can troubleshoot this. Out of the furnace, I have a yellow, a red, and 2 blues. Okay, so the red is going to be 12 volts plus, the yellow is going to be ground, 12 volts ground, and then the 2 blues are the 2 wires that leave the furnace and give it the call for heat signal. Let's follow the 2 red. Oh, okay, and then up here on the control board, I have 1 red, 1 brown, and 1 yellow. Now, if you have a, oh gee, what color is the other one? I could go look real quick. If your furnace has a time delay relay, you're going to have your 3 wires right here. If you don't have a time delay relay, that means that the timing is done on the board itself, and you're going to have more wires here. But on this one, let me move the camera over just a little bit. On this one, we have this time delay relay, and let's understand this for a second. Okay, so over here, I'm cleaning up some of these wires. Here's a red and a blue, and you see that they are paired together. Okay, and then opposite this wire is a red wire that goes straight into the motor. Then I have a green, and then I have another pair of a blue, and then this high temperature white. Okay, so let's just talk about this time delay relay for a second. When power, this red wire here that's paired with the blue, this is the always hot wire. As long as I have power coming to my furnace through my fuse and all that, that means this red wire is hot. It's the same red wire we saw over here feeding with the red and the yellow. Okay, so they daisy chain off of the red wire, and they're going to feed this blue wire below it. The blue wire below it is the one that's going to go into the RV 12 volts hot. This is what I was talking about earlier with the air conditioners and the ceiling plenums and the thermostats and all these types of things. So we're going to feed 12 volts hot on this blue wire going up into the RV, waiting for a call signal. That is to say that the furnace is self-contained. It can send the 12 volts out to some kind of a switch, and then that switch gets switched as a call for heat, and it comes back to the furnace. When it comes back to the furnace, it's going to come back on this blue wire right above it. Okay, so what that means is when there's a call for heat in the RV, this blue wire here that's paired with the, in this instance, the white one with the high temperature jacket on it, that is going to do 2 things. The first thing it's going to do is there was a call for heat in the RV, therefore this second blue wire that my finger's on, let me point with the, let's do this. Okay. So the first blue wire was this one, which is paired to the one that's always hot. That's sending 12 volts into the RV. The second one is this blue wire that comes back. Everybody seeing that? Where am I pointing? Good. Okay. I'll stay with this. So therefore, there was a switch made inside of the RV, whether it's from a thermostat, a wall thermostat, an air conditioning control thermostat. Somehow, these 2 blue wires touched, okay? There's a bunch of different ways to do that. So he's going to come into this time delay relay. It is going to... I'm going to go into the relay, but before I go into the relay, we're going to piggyback, and we're going to go on this white wire right here. The white wire is going to go on this furnace. It's going to go to the back, which is going through our high temperature relay switch. If there is a blockage in any of our ducts, or the furnace is getting too hot for any reason, typically we see that when the ducts are blocked somehow, then all that heat backs up inside of the furnace, and that switch trips opening. Okay, and that will basically tell the control board that it's an open circuit. I want to be careful how I explain all this. I don't want to confuse people, but basically the call for heat signal came back on this blue wire, and it's going to go through several little stops along the way. Any one of those stops could open the gate and could open the circuit, preventing the call for heat signal from getting there. The thermostat could be satisfied, the high temperature switch in the back could trip open, or here we have the sail switch. Is the sail switch in my shot? Yeah, okay. So the white wire going to the back goes to a high temperature switch. I haven't talked about the relay yet. I'm going to save him for a moment. I'm going to spend a moment on him. It goes to the high temperature switch. If I am making it through the high temperature switch, I come back on this black wire, Okay, so I leave on the white, come back on the black. This is my sail switch. The sail switch will be open at this point because there's no wind blowing it. You see on the bottom, can everybody see me doing that? Okay, good. This is the arm on the sail switch. It's inside of our blower wheel, the blower cover. And so as wind is created at the blower wheel, the switch gets made, okay? And then so as my switch gets made, we have 12 volts came in on blue because of a call for heat. I went to my white wire to the back and I got a, okay, I'm not overheated signal, and it's normally closed. It only opens if it gets too hot. But anyway, I come back on this black wire that's got this high temperature braid on it, and I'm sitting right here on this pin on my sail switch. Sail switch is open, so I'm just going to sit here. And as I'm sitting here, I'm waiting for I'm waiting for my motor to start. When the motor starts, the sail switch gets made, allowing the 12 volts to go through the sail switch onto this red wire right here. And the red wire here is the one that we saw earlier feeding into our control board. This red wire is the one on our control board that basically says it's okay to to open the control valve, to open the gas valve, allowing gas to flow, and start throwing matches in the thing to see if you can get ignition. So, real quick, coming in on blue, coming in on red, piggybacking on blue. Blue then goes into the RV. I come back on a signal on blue right here. I'm piggybacked. I haven't talked about this yet. I go into my high temperature switch, and my high temperature switch is not tripped open. Great. I come back on black, and I'm going to sit here on the black wire. And as soon as my motor starts, then my sail switch closes, and then I send 12 volts on this red wire back to the control board, which we talked about originally. Got it? Now, this relay, what's up with this? I have 12 volts sitting on this pin right here. Okay? Opposite this pin is this other red wire that goes directly into the motor. Therefore, I have 12 volts coming in, and if my relay is closed, I'm passing 12 volts from this red wire that's piggybacked with blue directly through my relay into the motor. But in order for this relay to work, basically a relay is an electric switch, a switch no different than one you might find when you go turn on the lights. It's just a switch, but it's an electromechanical switch where you need voltage in order to close that switch. All relays have different coil voltage ratings. This one is rated for 12 volts coil voltage. But I could have this be, if we're into electronics, I could have a 3.5 volt coil, I could have a 5 volt coil, a 12 volt coil, a 24 volt coil, 120 volt coil, 240 volt coil. You get the idea. So that is the current that I'm sending this electromagnet is based on the coil voltage. All of these are 12 volt coils. So what we're doing here is we have 12 volts sitting on this pin, and when the electromagnet gets made from the 12 volts, it's going to close, feeding power into our fan. Now, this is a time delay relay, which means that when I give it 12 volts power on my blue wire, because I just came back from my thermostat in my RV, when I give it 12 volts blue wire, yes, it's also going to go into these other things, but I'm going to start heating up inside of this relay. Now, all relays are not the same. This one has a like a bimetallic element in it that as it gets heated up, it will change. It'll snap open or closed. So in this instance, I'm giving it 12 volts. It's starting to heat up, and as it heats up, it starts to close. Or once it heats up at a certain point, it closes. Some engineer somewhere figured out exactly how much current, how long, and usually we're looking for about I don't know, 18 to 20 seconds is somewhere in there. These types of relays, it's not like you're sitting there with a stopwatch. If your voltage is higher or lower, it's going to affect how quickly these open and close. But 12 volts is coming through, and then that leaves this green wire, which is basically ground. Okay, so 12 volts is coming in. Inside of this relay is a coil that I need to give 12 volts, and then I need to reference ground to it. So I'm referencing ground on this pin, giving it 12 volts on this. I give it some time, 18, 20 seconds. The thing closes, allowing the power that's sitting on this side to pass through the relay and go straight to my motor. Make sense? There are some aftermarket relays that you can replace if these relays go bad. Some of them don't look the same as this. And some of the challenges is figuring out what all these pins do, because there's 4 pins. Sometimes when you look at them, and sometimes what I'll do is if the relay doesn't look like this, I'll take my meter and take 12 volts, and I'll just energize the pins until I get it to close for me. Then I know I've got the coil pins and I've got the primary pins. And some of the coils have secondary pins, normally open, normally closed. So that's what's going on with this relay. I wasn't planning on getting into all that, but I wanted to share all this with you, so as we start taking our meter and probing things, we'll be able to see the voltage on different locations. Okay, so okay, I've moved this furnace back a little bit and got my meter here so you can watch it. So the first thing I'm going to do is I'm going to probe into this red wire that is hot all the time coming from our battery. So I'm just going to probe in there. My meter tells me I'm at 12.5. So if I'm at 12.5 there, shouldn't I also be at 12.5 right here? So let's probe right into there. There's my 12.5. Okay, so I'm on this bottom pin right here. Therefore, I should also have 12.5 on this blue. So let's go find the blue. Let's see, is it on this one? There's my 12.5, which is red. And these are the two wires that I'm connecting together. So if I go inside of this guy, I'm at 12.5. So what did I just do? I just proved I followed my trail. I've got 12 point, I'm just call it 12. I got 12 volts connected to my red wire feeding the furnace, which comes over here. We've proven we have 12 volts right here. I'm right on top of this flag connector. And I'm grounded. I'm using the reference to the frame of the furnace to reference ground, okay? So I'm tapped into the top of the flag connector here, and I've got 12 volts. Piggybacked off of the blue wire. The blue wire comes back over here, and it goes into the RV. It goes into the RV on this red wire, and we see it. Get this thing back. We see it sitting on this right here. Okay. Great, there's my 12 volts. So therefore, when I become the thermostat, this little orange thing is going to represent the thermostat. So basically, it's just connect the wires. And where I expect to see it is right in here. So let me stick my meter right inside there. Okay, I think I got it. If not, I'll wiggle it. So watch the meter, and when I connect this, I'm basically putting 12 volts back on this blue wire, okay? So everybody sees the meter? Yep, okay. So here we go. We're gonna look for 12 volts right there. There is my 11, which is 12, coming in on this blue wire. Now this relay is heating up, and I'm gonna have it on this wire right here as well. So here I have 12. Let me stop it real quick. I want you guys to see what I'm doing. There we go. Okay, the meter is wedged pretty nicely there. I want this to stop because what I'm going to do, and we have to wait for this relay to cool itself off. Remember, on this relay, there we go. On the relay, it got its 12 volts, it got hot, it closed, allowing voltage to pass through. We took our voltage away. Even though we took the coil voltage away, this thing stayed on because I've still got 12 volts feeding the main body right here. Okay. So what I want to do now is when I connect these, you're going to see 12 volts coming in on this upper blue wire with the white jacket on it. Okay. So there's our voltage right there. Okay. Our coil's heating up. Let's come down here real quick. Okay, so I've repositioned everything, and I want you to watch the meter, and what I want you to do is see this little lever down here that I'm clicking? You're going to watch that. Now, we know we have 12 volts on this top pin. We've proven that, but I've got my meter wedged inside the sail switch, and even though we have 12 volts on the top, you will not see 12 volts down here on the bottom pin, which is the meter value, until the fan starts. Okay, so let's go ahead and do that now. I'm going to connect my thermostat wire. I've got it's out of the frame here, but my relay is heating up. It's heating up. It's heating up, and about an hour or so. Okay, the fan. So there's my voltage coming in, but it wasn't there originally. It only showed when the fan got made, and I wanted you to see this paddle move when the. So I'm not going to go look, but hopefully, and now he's trying to ignite. So let me turn him off. I've opened the relay, I've opened the thermostat call for heat, this orange thing right here. And so anyway, I went through all that so you can actually see the parts moving. And there's one more area I want to show you real quick, and then we'll get busy fixing this thing, okay? So let me pause and reset the camera. So now I've got my pin, and what we're looking for is voltage on this red wire that's coming into this white connector, and you should be able to see the meter down here. So we are, now, if there's voltage on the red wire, that tells us that the current has made it through the high temperature switch in the back, made it through the sail switch, and is now telling the board it's okay. like fire in the hole, you know. There's a call for heat. I'm not overheated, and my cell switch is happy. Okay, so we're going to connect these two together again. Okay, so our thermostat is heating up. Nope, there it is. As soon as the fan started, I had my voltage. Okay, now let me go in here to brown. Okay, so no voltage on the brown wire. The brown wire is my gas valve. Ignore the squealing, we're going to fix that. So we're going to look at the brown wire. There we go. And there was a click inside the board, and our voltage came on the brown wire, which is turning on the gas valve. Okay, so all this is to say, now the yellow wire is ground, so we could reference ground, but you see I've got it right here grabbing the frame. So now that I've gone through all that, let's benefit from this furnace having an intermittent issue. If I want to eliminate the sail switch and the high temperature switch as the problem, then I can reference this red wire up on top. Let me simulate that for you. Okay, so now I am connected to the red wire up on top, and I'm just gonna disconnect the red wire over here. Okay, so let's just say that our sail switch faulted out. Okay, so I'm gonna unplug this. If I will let me, there we go. So I've just unplugged it. The red wire lost signal, and now I'm going to reconnect it again, indicating that the signal came back. Now let's see if this furnace will ignite again on the red wire. So our red wire is telling us that high temperature switch and sail switch signal. So therefore, in order for there to be voltage on this red wire, it started back up again. Okay. And I remember earlier in my talking points, I said that sometimes it won't. So if my voltage on my if I'm diagnosing an intermittent problem on a furnace, and I'm looking at this red wire right here, and that voltage on the red wire comes and goes, and coinciding with it coming and going, my furnace extinguishes and ignites, then the problem is with that red wire. The problem is with the sail switch or the high temperature switch or a call for heat signal. Okay, that's what I wanted to show you guys. Now let's probe down here with my brown wire. Okay, now I'm checking the brown wire. Now this is assuming I can get to the front axis of my furnace. So you still see my meter? Yep. Okay, now I'm on my brown wire. And let's see, how do I fault him out? I'm going to turn off my propane. Okay, so I'm going to turn off my propane, indicating a loss of gas. Okay, and you will see I've lost gas. Voltage to my gas valve is still open. There he goes, he closed. So the gas valve stayed open. Now, real quickly, do I still have voltage on red? I still have voltage on red, therefore there's still a call for heat, therefore I'm not overheated and my cell switch is good. But look, my furnace is extinguished and I do not have voltage on brown. Let me get it in there. Okay, so now I'm at 10.5 volts. The furnace is going through what's called a 3-second try. He's turned himself off, he's gonna try 3 times, and he's gonna go into soft lockout. And we're referencing the brown wire here. He's gonna try one more time. What's making this decision is this control board right here. The control board's going to energize him one more time, and after that he's going to say, all bets are off, I'm not going to try anymore. Some of your furnaces will have what's called a soft lockout. Soft lockout is when I try 3 times, I cannot get it to ignite, okay? And at that point, I will basically, in my brain, start a timer for 1 hour. And after 1 hour, I will try 3 more times. And after that 3rd time, then I will go into what, and not be able to ignite. I will go into what's called hard lockout, and that means I will never, ever, 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 ever try to start ever again. Okay? Because I've tried 3 times, I couldn't. I waited an hour, I tried 3 more times, I couldn't. Therefore, I'm never going to try again, and we call that hard lockout. All you have to do to clear any of these lockout conditions is turn off your call for heat and turn your call for heat back on again, and it will start. Now what's happening is this furnace will run forever and ever and ever and ever as long as the thermostat is calling for heat. Now why is it going to do that? Okay. So here I'm probed into the red wire. I've got my voltage coming from my battery and everything. But let's move back over here. Well, can you guys see right here? Okay. Why is this furnace running constantly? Let's move the meter, let's move the camera over again. Hold on for a second. So the question is, this thing's going to fall on me. Is there a glare? No, we're good. Why is the furnace running constantly and it will not try to ignite? We already know that the furnace is in a lockout condition because it's tried 3 times and it stopped. So why is the furnace just blowing forever and ever and ever? Anybody want to guess why? It has to do, let me get a pointy probe here. Anybody want to guess why? Well, we still have voltage coming in on our relay here, don't we? Yep, I've got 10 volts, which is basically 11. The question is, do we have a call for heat voltage, which is right here? I do, okay? So there's still a call for heat, and this furnace isn't smart enough to know that there's no flame to keep running. The problem is this relay here is still being told to run the fan. Let me get it in there again. Right there. And that was why I was going through all this stuff earlier, because there's still power on this blue wire coming back from the thermostat. As long as there's power coming on this blue wire back from the thermostat, I am energizing my coil of my relay. My relay is still being closed. It's still allowing the power to pass through to my motor. Okay, so this furnace will run forever and ever and ever and ever until somebody goes inside and turns the thermostat off. They do have they do have control boards that will fix this problem, but as long as this relay is separate from the control board, it does not understand that there's no flame. It's not that, there's no connection between this relay and that control board to say, my flame is extinguished, therefore turn off. Okay, so that's why your furnaces will run forever and ever and ever, blowing cold after it's tried for 3 times. Now, I made a statement. Let me move everybody back over here. Hold on. So it's been quite a while, and this furnace has constantly been running, blowing actually cold air right now. And we understand the reason why is because the relay is still told there's still a call for heat. Another thing you notice is that it's this squealing thing is coming and going. It's very intermittent. So therefore the customer is like, well, I could live with it, but we want to get it fixed. But there was that intermittent problem inside, which we haven't seen yet, but I did see it in the RV. So what I want to do now is turn on our propane cylinder, okay? And the furnace still won't start, because remember, it's in lockout. And what did we say was the way to clear a lockout situation? This is representing our thermostat, so I'm going to disconnect our thermostat, okay, and I'm going to reconnect our thermostat. And let's go into the brown wire here. There we go, okay. And everybody see the meter? Yeah. So, the meter good? There's a glare, but anyway. So, there it goes. There's my coil voltage going to my board, and I'm shooting a signal. So, at this point, if there's an intermittent issue, I've gone through why the furnace is running forever. Let me turn it off. Okay, I've opened the thermostat, coil went away. And now the red wires are going to be power on our red wire. Right there. Look, there's no power on our red wire. I'm always aware of the glare. There's no power on our red wire. Why? Because there's no more call for heat. There's no more call for heat because I just told the thermostat, go away. But I would have gotten no power on my red wire if I got too hot back here, or if my cell switch faulted. Okay, it's just one red wire. The board's not smart enough to know that it's the high temperature switch or the cell switch or the thermostat. It just sees there's no more power on my red wire, therefore I'm going to begin my, basically this is going to extinguish everything, and the only thing we're waiting on is for this relay to cool down and open the circuit, therefore killing power to the fan. Okay? So, where do we go from here? We went pretty deep. So let's go back to the original problem of, I know we're going to be replacing a motor, okay? But let's go back to the original problem of this intermittency, okay? When I had this, there we go. I'll tell you what, let me reset. So coming full circle back to the original problem, okay, so I went through, I don't know how long that took, but I went through all these wires and we followed the trail through all the circuits. So when this furnace was having the issue, I had an access door on the outside and I was able to probe these wires just like I showed you up here in the front. And the red wire stayed 12 volts hot all the time. Since the 12 volt wire is staying hot all the time, I just eliminated it being a cell switch or a high temperature switch, didn't I? Because if this thing's staying hot all the time, hot being 12 volts power, then but the brown wire kept coming and going, then the board was having a difficult time detecting the flame. So therefore, it's got to be the electrode. So I wanted to go through all that so you see maybe how to troubleshoot why would a furnace be intermittent. Is it the sail switch, high temperature switch, and on your Atwoods and pneumatics, the high temperature switch is going to be on the front. Some of your Atwoods, oh, it's terrible. You got to take the whole motor apart just to get to your high temperature switch. It's terrible. This one's easiest on the back. Over the years, these things have changed several times, but the principles are the same. This one's got the thermos time delay relay. This is an older one. A lot of your time delay relays are gone now, and the counting is done directly on the control board. And you can upgrade yours to do that. You got to do some wiring changes, but the furnace doesn't care. You can upgrade these to like a Dinosaur Electronics fan, 50 plus pins. You are going to need to do some wiring changes, but it could be done. Okay, I've done it many times. Just get rid of this temperature relay. You got to make your wires longer and bring them over here to the board, because then this fan wire then is controlled from the board, not from this relay. Okay, so let me just keep going here. We have eliminated, you have not benefited as I have, seeing this furnace intermittently extinguish itself. You haven't benefited from that, but I'm telling you that it did. And when it was doing it, I was constantly having power on my red wire. Therefore, we knew it's not the sail switch. We knew it wasn't the high temperature switch. Okay, had this red wire come and gone coinciding with the extinguishing and igniting, now we're looking at a sail switch problem. Now we're looking at a high temperature problem. Now we're even looking at a thermostat problem. Okay, but because the 12 volts stayed hot the whole time, and it was a brown wire that was coming and going, then now we're looking at this electrode right here, this like spark plug looking wire that goes up inside of here. So to fix that, we need to go inside this cover, and it's a bear. I'm going to save everybody the trouble. I'm going to just do some magic editing, and I'm going to pause everybody. You need to watch me. What I'm going to be doing is taking all these screws off, okay? And then down in here is a 5, I've already got myself set up with it. I'm gonna use one of these 5/8 crow's foot things, and I'm gonna stick it in there, and it's a bear, but I'm gonna get it loose. I'm gonna save everybody the trouble, do some magic editing. I wanna make this video seems like it's going long, and I can tell because it's getting dark, but I want to get in here and I want to see what's going on with this electrode. So I'm going to pause everybody, get into this thing, and the next time you see this thing, we'll have the electrode out. So you don't have to watch me do this. I'm basically taking off all these screws and loosening this 5/8 nut, and I'm going to pull it out. Okay, so let's do that. So I've taken all the screws off, loosened this nut. These things are bare. You take your crow's foot wrench thing, stick it in there, and pivot. You can only move it so far. But anyway, I've got that loose, got all the screws off, and this lifts right off. Okay, so there we have that. I've done other videos where we do a complete service on, and so I'm not going to spend the time about the orifice and all that. Go watch other videos to learn about the orifice and the fittings and all this kind of stuff. What we're after is the electrode. Let me see. Okay, so whenever you take these covers off, you need to replace this gasket. I will provide you with the part number for that. I stock a bunch of them because we're into these things a lot. Here's your electrode right in here. So we've taken the cover off. Your electrode is right here. I'm touching it. Okay, nice and convenient. You have to take all this apart just to get to the electrode, but you need the electrode to be right where the action's at. So I want to evaluate that. I can feel right here. I can see the problem. Okay, I want you guys to see what's going on here. Okay, so I've tried to keep the electrode in its native state, okay? Now, when we're looking at this electrode, we do want there to be an 1/8 of an inch gap. I've got other videos where I talk about how to establish that gap, and you make a little crisscross, you shine your flashlight up into this burner. But what I'm detecting, now I can feel it with my finger, I'm not gonna try to get the camera angle, but a lot of times, this thing is loose, like a loose tooth in here. I should not be able to move this electrode so easily. Okay, so it's loose inside. So this electrode is loose inside of the ceramic, is what I'm saying. So remember, I was saying that this intermittency will be because the control board cannot detect the flame. If this electrode wire, I'll call this the wire part, is loose within the ceramic, then that will cause this to have some intermittent faults. So where they bond the orange, I'll call it a spark plug gauge wire, over to this metal inside the ceramic, sometimes those fault out, and that seems to be our issue right here. So let me pull this, yeah, that's really loose. So what I'll do is I'll pull this electrode out, and I'll try to get a close-up and show you what I'm seeing in here. So again, I'm going to do some magic editing. When I'm recording for you guys, I love doing that, but it does make things go a little bit longer. And so all I'm going to do is take 1, 2, 3, 4 screws out. Right down here, I'm going to pull this bracket out, and these 4 screws, I'm going to pull this electrode out, okay? And so let me move you guys out of the way. Let me get that done. I spent too much time talking about how these things work and went over the electrical, and I really need to get this job done. So I'm going to go a little faster, but let me get this electrode out, and I'll show you what I suspect is a problem. Okay, so I've got these covers out, and let me just show you. I'm going to grab it here, and what I want you to do is I want you to watch right inside of this part where the metal electrode goes inside the ceramic. So when I wiggle this, there's a lot of movement coming from inside of this thing. Okay, I could twist it and move it around, and that is an intermittent. That's where our intermittency is coming from. I should not be able to move this electrode like this. So as opposed to, here's a brand new one that I just pulled out of my service trailer. So here's a brand new one, and when I try to move it, that's very stout. Okay, there's no movement going on in here with, like, I could force it to move is my point, but not as much movement as here. There's obviously some movement going on here. You can see it moving back and forth. Okay, so there's our problem. So what we're going to do is, it's too bad that I couldn't get this thing to fault out when it was on my bench, but it was faulting out in the customer's RV. So here we are, a new electrode, and it's very stout within this ceramic. So let's zoom you out. You guys can watch me fix this. Hold on, let me set you right up on that. Okay, so I'm just going to set you guys up right there, and I'm going to just get busy. So this is one of these pieces that comes out if you have it in there. Now they've changed their design a few times, but on these Suburbans, this piece right here kind of just comes off with this little clip. And so then for this, we're going to come around here and unplug that. Pull it through. Okay, I've already snipped the cable ties. I did that already. And we're going to pull the electrode out. Okay, and then we've got these little, I don't know, like these little orange strain reliefs, grommets, if you will, that are lovely to play with. Okay, electrode comes out. So here's our electrode. Now your electrode is going to come with these little grommet things. So I'm going to just try to go fast. I need to get this done. So sometimes what I will do, guys, is just pull the grommets come off the end. Okay, so you just take it off, and I'll put it in my tray. So we're just going to pull him through. Okay. And there's the old one, and the new one. Where to put the new one? Ah, okay. So here's our new one, and we're going to go in through like this. You know, I probably could have, okay, I just was thinking, take this grommet off. We'll go with the new grommets. Okay, so what I will do is take these grommets off. It's these clear things. I'm just going to take them both off. All right. Now on these, I got some holes. For your benefit, I'm going to go through the big hole here on the bottom. Everybody see that? Okay. I'm going to pull it through, and I'm going to double back up through that like that, kind of like tying a knot. Okay. And then I will take a grommet. I'll take a new grommet, slide it on. Cats are being silly. Slide it on there like that, and then I'll take a little plastic window tool to kind of help me get it in there. I don't want to take a screwdriver. I might nick the conductor, and I don't want to do that. So the chance of it doing it with this window tool are next to nil. Risky without gloves. These things have drawn blood before. I'll tell you what, you guys don't have to see me fight for this. I'm going to put this grommet on, Okay, I'm gonna put it right in there. I'm gonna feed this back through and with another grommet right here, and I'm gonna get my wiring done. Okay, so I need to pick up my pace a little bit. So when I come back, this will be threaded. All right, so stand by. All right, so I've fought this. I remembered a trick that I had done previously. What you do is you take your grommet off, feed your grommet into your hole, and then feed your wire through the grommet again. So that makes these a lot easier. That makes these a lot easier to fix. Okay, so when it's done, it's gonna look like that. Okay, very well. Okay, I've also got my grommet in here, and now I will feed the electrode through the grommet and then into the second strain relief. There we go. Just snugging it through there. Very well. And now, you know what, since I've come this far on this furnace, a best practice that I do is for 2-3 more screws, I can pull this burner out. And that's just something that I will do for the customer's benefit. I've come so far, what's 3 more screws, right? Just to do a visual inspection on this burner head. So we'll do that real quick. A lot of times these things will show a sign of a cracking right in there, so I'm looking at that as well. So when I'm coming this far into a furnace, yeah, let's go ahead and take this burner off. What'll happen is so it was in here like this. Okay, so what'll happen sometimes, you'll have a hole burn right there, and that hole is from LP oil in the LP line. Okay, and then you can look inside. So this looks really good. I see no problems with this. So that, oh, there's a bee, a dead cooked bee, crunchy bees. So yeah, that looks good. So that didn't take too long, and it's not anything I'm going to charge for because I'm already into the furnace, but it's just another thing we can do for the customer. Okay, wonderful. Now I'm going to check for my gap. I say I have an 1/8 of an inch. We're going to rectify our flame. So I get an Allen key. I used to put yellow paint on it. They're all rusted. Get a paint pen, find your 1/8 of an inch key, and put paint pen on it. And that looks good. Yeah, okay, so we're an 1/8 of an inch. That's what you want, 3/16 to an 1/8. The gap is a function of the diameter of the electrode. So we're good there. And I told you guys we're gonna put a new gasket on it. So let me run over and get that, and I'll share the part number with you guys. So if you go into here, you can get your part number before you go into it. Okay, so let's dig in. What else is in the box, Jeff? Okay, so here's your serial or your part number for your gasket. Okay, and so we're just gonna cut this open. So you're gonna get a brand new gasket. Yeah, don't put the old gaskets back on. Spend the $2-3 to get a new gasket. It is important. Okay, so we're going to put that on there. So we've checked our burner, we've checked our electrode gap, we've got a new electrode on there. The old electrode, now that I have it loose, you can see he's just, you could feel it. You could feel an audible movement inside of this thing. And so this would cause intermittency in a furnace, okay? We've certainly discussed at length what other things it might be. So another thing is this orifice Okay. A lot of times you might have, we had a customer drive all the way from South Carolina all the way up here to our Olympic Peninsula because multiple other technicians could not figure out what was wrong with this furnace. And when he explained to me what the problem was, I knew what a problem was. There was an insect nest, little bitty bugs that had gotten inside of this orifice. Symptom would be you smell the gas, but you have no ignition. You hear the ticking, you prove there's ticking, you can see the ticking, everything's ticking, ticking, ticking. You smell the gas, smell the gas, smell the gas. No ignition, no ignition. I want you to look at that orifice right there. Sometimes those are clogged. Enough to let the gas go through, but in order for LP to ignite, it needs a certain ratio of gas to oxygen, okay? So there's that. Now, these can be a bit of a bear to install, so we're gonna go right down inside of there. A lot of times, not a lot of times, I will always put a screw in, not tight, just loose, because I want to keep that gasket square. I want to keep it there. So I'll go over here. I don't want it to be tight. I want it to be a little loose because I want to be able to move this thing around a little bit. So my gasket is in place. I can still move this thing around. Here's a part where I don't like this part. I like working on furnaces, but I hate the part I'm about to do. What I've got to do is get my hand inside of this small little space and turn that nut and hold this gas valve all at the same time. And I wish I knew a best practice or a trick. I've never not been able to do it, but it sometimes has lost 45 minutes trying to get it to go. Maybe not that long, but it seems like it takes half a day to get these things to align. Some of my best practices, though, I'm just going to leave the camera there, guys. I'm not going to try to get it moved. I'll share my best practices with you. Here's the tie wraps. I'll put new tie wraps on. So some of my best practices when I try to get this to align is this is the gas valve that I can move around, and I can also change the angle of it right here. So I know that I want this part of the stem. Now, you're not all going to have the same configuration, okay? So basically, I've got to take my hand, fit it in here, and sometimes you get it right away and sometimes you don't. You just gotta wiggle. Did I just get it? Oh my gosh, hold on. I'm not so confident that I got that. Sometimes you get it right away. And oh my gosh, I'm gonna go play the lottery, big one, because I just got it right on the first turn. That is not my experience. Sometimes I'm kind of excited right now. So what we're doing right now is, if you could look inside of here, let me put on a headlight. Where's my headlight? I think we're gonna break this up into two videos, and I'll do the motor on another. I don't know. It's just that these things are getting, this video is getting so long. So where we're going for is inside of here. Can you guys see in there? Yeah. Okay. We're trying to get that nut on the gas valve in this small little space. And so, yes, you get like a little turn each time. You see what we're having to do. Okay. So now that we understand what we're doing, let me turn it. But yeah, getting everything to align is a bit of a bear. So holding the gas valve and keeping your eyeball on this pipe over here is helpful because you get an idea on what the proper alignment's supposed to be once it's all snug. So that would be the only best practice I can share on getting these things aligned. Like I said, and you only get like one. Okay, I just snugged it. Okay, so he snugged it. All right. Ratchet. And we're gonna go mill right tight. Okay. There we go. It could be argued that this here, it does have to be gas tight, but it is going to an open orifice. Okay, so we are sure that that's tight right there. We could do a sniff test on it. And, okay, so now we tighten this down. You didn't watch me take it apart because I was trying to save some time, but I'll just keep the camera rolling and you guys can enjoy this. case you're wondering, back here is where all the grounds connect. Remember the green wire we talked about? It seems like hours ago. Here's the green wire, connects to ground. And so when I was grounding my probe to the frame, I'm basically touching ground. And so here's our new electrode wire. Get a couple tie wraps here. Great, they went upside down and now they're all spilled. I am not a fan of bonding the electrode wire right up next to, I'll put them under the same tie wrap, but I'm not a fan of bundling it in with all the others. It's all DC and millivolts and everything, but in the AC world, when you have an AC wire on a DC circuit, you do want to keep those separate because of capacitive coupling, where the AC will induce itself onto the DC current. So since this is shooting very microamps, I do want to keep them a little separate. So I've never seen it cause a problem, but I do like to keep them as separate as I can. Okay, so now we come up here. There. So I'm going to visualize all the way through. Yes, we're good. And I think another thing I might do is just go over into the compressor and just blow this thing off. But here, remember the white and wires? Okay, since we're here, let's turn this on the back. Something you haven't seen yet is this. He's awfully loose. That's very loose. Okay, so we're just going to take our needle nose pliers and just try to crimp that connector a little bit. There we go. If that doesn't work, we'll replace the connector, but sometimes it just needs to be, that's better. Okay, a little bit tighter on one side. Make it grab a little better. Yeah, if that, oh yeah, that's nice. And this guy's good. And this guy's good. Okay, so we just needed to close those up a little bit. But this would be your high temperature. This one doesn't have a dot on it. Typically these are green dots. So then you would go by the part number. This one's what is that, 231799, which is going to be an old part number, but there's going to be cross references. And since we're talking numbers, oh my gosh, this video is going to go forever. What is our serial number on this little jewel here? And serial number is 9719 blah blah. So this thing was manufactured in 1997. That's the year I got married, 1997. So the model number is an SF30F, but the serial number is a 97, and it goes on. So 97 is when this came out. Okay, we've replaced our electrode. Lovely. Now I'm at the point in the video where I got to decide, do I keep on going with you guys or stop and make another video of me replacing just the motor? And what I'm inclined to do, since it's getting dark, and you know how I like to ramble and go off on all these long, tall stories, I think what I might do is break this up into a separate video where I just do a motor replacement on it. And we'll call this video the one where we talked about the intermittency of the issues, okay? And I think that that will give value to everybody, okay? And it is getting dark, 7:19, the sun's going down. I even turned the lights on my service trailer and it's just not gonna work. So yes, that is the command decision. I'm gonna take this over to a compressor and blow it out, all this stuff. But I think I am gonna turn this into a second video where we do the motor, because I gotta go into all this thing. You know, folks, this video, I have a feeling, has gone kind of long, and I still need to replace the motor, and I don't want this thing to go off and have you had watched this whole thing if you really wanted to know how to replace a motor. So I'm going to break this up into two videos. The first video is going to be the intermittency of how these furnaces might fail, and we'll talk about all the different parts. So, hey, if you've gotten this far with me, I really appreciate that. I know I probably went a little long on some stuff, but hopefully from it you gain some value on how to troubleshoot these older furnaces that don't have that have the time delay relay, that don't have the control on them. I don't know that I went this deep on a furnace with this information. So thumb it up, share it with your friends, show it to your RV technician, because I've gotten a lot of reviews that RV technicians just said you needed a whole new furnace. It's terrifying that people will say that when all it was a little, what are these electrodes, 20, 30 bucks? And now the motors aren't cheap, but Suburban does have the core exchange thing that you can look into. But I'm going to stop and thank you for your time. I really appreciate you guys, and I liked reading all your comments. I'm not able to reply to every comment because there's quite a few of them when you have as many videos out that we've done. But I'm going to continue to make videos for you guys, and I like reading your comments. It helps to steer the direction I need to go with all this. If you are interested in starting your own mobile RV service business and have service trailers and run your business like this, what I do want to invite you to is check out our Patreon channel. We'll have a link down below because we do have a series on there on how to start, build, maintain, and operate your own mobile RV service business. Basically, we've literally thrown the doors open of our business and let you kind of walk around inside and ask us questions, and we'll do everything we can to help you get your business started and you can be successful at it. It's really been a blessing to my life. As you guys know, I was a high-level, highly paid engineer doing automation jobs at industrial levels, and I started this gig around 2011, and I'm my own boss. So it's really wonderful. I get to be with my kids and my wife all day long if I wanted to. So I want that for you guys as well. And we are certainly needing RV technicians throughout all over the place. We would really benefit from that. People that really know what they're doing and run their business, honest with integrity. So that's what I would help you do. Anyway, so I'm going to wrap this up. Happy camper, same RV works. And I think that now we've fixed the intermittency problem of this electrode right here. And now we'll get the motor fixed. So I'm going to land my plane and pull into the terminal and let everybody get off and go watch your next video. But hopefully it's one of ours. So we really appreciate that. So, hey guys, appreciate your time. Thank you for watching my videos and for your comments. All right, bye.